Hello and welcome to this new lesson in which I will talk about digital multimeter. This is a quick introduction to this device. The one that I will be showing you is Unity, as you can see. Okay, let me show you a few things. Now, this device is basically used for showing on this LCD, showing digital readings for volt, ohm, ampere and other stuff that I will talk about now. So let's take a quick introduction to the basic components here. Now, if you looked at the bottom here, you will find there is a COM, which is the common. Usually, we connect the black wire to this opening or this hole. And here we have like 3 openings, each one with the type of the thing that it's used for measuring. So this one is used for measuring 10 amp max. So 10 amp max, if you placed any device that will consume more than 10 amp, the fuse will be blown. So this one is used to measure current in milliamps, and it's used also for measuring the temperature in Celsius. This opening is used for measuring volt, ohm, the diode and the hertz. As you can see, each of these is used for a certain thing. You can't use it for any other thing. Now let's move up here. As you can see, we have this LCD display. It's used for displaying the results, and if you take a good look at it, you will find that it has a lot of things. Now we have the power button here. If you clicked on that button, the display will turn on. We have the hold button here. If you click the power button and took a reading, then press the hold button, the reading will remain on this LCD display. It won't move. As you can see, it's stating hold. Okay, now this is a quick introduction. Here in the back we have like something that can help keeping this up if you want to use it and to take readings. Now let's take a quick look at this dial. As you can see, you can move it away to choose different things. Now if we turned on the power, let's start from the bottom. Let's start with the ampere. As you can see, here we can measure 20 milliampere, 200 milliampere up to 10 ampere AC. As you can see, A with this sine wave shape means this will be used for AC readings. And if we moved here from 10 to 100 milli and 20 milliampere DC, this constant line means DC. So these 3 will be used for DC readings. And if you want to measure the hertz, we will move this. It will measure up to 20 kilohertz. If we want to measure the capacitance, we can measure from 2 nanofarad to 200 microfarad. As you can see, you can change the reading from here. If you want to measure the temperature, you can choose this one. If you want to measure the other readings, such as diode or connectivity, you can choose from here. Let's move on. This is the ohm reading. Okay, let me just, what you can see here, we have starting from 200 ohm, 2 kilo, 20 kilo, 200 kilo, 2 mega, 20 mega, and 200 mega ohm. So all of these can be used for reading the resistance. Next we have these readings for volt. As you can see, there's a constant line, so volt DC, starting from 200 milli to 20, 200 and 1000 volt. Here is the same. We have volt with the sine wave shape, which means AC volt, 220, 200 and 750 volt AC. So you just need to move the dial to this point so that you can take the readings in volts, and it will adjust itself or the LCD screen. Now one thing that you need to know before moving on is that when you choose the reading from here, if you want to measure volt AC, you have to connect the wire. You have to look here. Here we have the volt, so I will connect the red wire here and the common here. Then I will measure volt. If I want to measure ampere, let's move. I will move to ampere, as you can see here, 10 amp DC. And since I'm measuring 10 amp, I will put the red wire here and the black wire here. These are the wires that I'm talking about. Let me show you. These are the two wires. This is the red and this is the black wire. The black is usually connected to the common, and the red is usually connected to one of these three, depending on the dial movement. So if I want to measure hertz here, as you can see, I will go and choose hertz from here. That's it. Make sure that before moving this from one to another, you turn off that LCD display, because if these two wires were connected to something and you move, let's say, from hertz to ampere, it might break your digital multimeter. So make sure to turn off before moving this wire from one type of reading to another. That was a quick introduction to how to use a digital multimeter to measure different things. We will talk in more details about resistors, capacitors, inductors, and other things, but that's it for now. If you have any question, please ask in the Q&A board.
Hello and welcome. Today we will talk about volt-ohm meter basics. Measuring electricity. The common function for volt-ohm meters is measuring voltage, AC and DC, and different ranges, measuring current AC and DC in different ranges, and measuring resistance in ranges and continuity, in addition to measuring semiconductor performance, transistors, and diodes, in addition to capacitors. As you can see in this slide, this is one of the basic ammeters or volt-ohm meter. This is the meter reading digits, and these are the scaling. DC voltage scale, as you can see here, there is a V plus a sign here. This sign means DC. AC voltage scale, as you can see, V letter plus an AC sign or sinusoidal sign. Function selection, as you can see, this probe is used to choose any function from these. It will rotate in any direction. Function selection, this one is for function selection. Probes, these two probes are used to measure the components. These are two wires that are connected to the components to be measured. And as you can see, this is a very basic meter. Now let's look about other components that this meter might have. As you can see here, there is DC current low. As you can see here, this measures from 200 microampere to 200 milliampere. This is for small DC current. This is for large or high DC currents, 10 amps. This is the diode checker. As you can see, this there is a diode drawn here. And this is the transistor checker. This is for resistance measuring, as you can see, starting from 200 ohm to 2000 kilo ohm. You can choose any of these to measure them. And I think that this is the most common type volt-ohm meters. Other type might have other functions, and depending on how much your budget is, you can choose any. As you can see, there is 3 probes here. This one is for measuring ampere in DC, and this one is for measuring voltage or small currents, and this is the common. It must be connected all the time. This one is moving from here to here depending on the amount that I want to read. And as you can see, it says 10A DC, which means that this will be used to measure the ampere or the current in DC, while this one is used to measure voltage, resistance, and the current in milliampere. So you have to be careful when dealing with these three probes. You have to connect each one to the right place as mentioned here. Now we won't use it in practical, we will use it in the experiment sections, but you need to understand how it works and how to use it. Let's see the volt ohm meter basics. We mentioned earlier that it will be used to measure voltage, voltage type, scaling, safety, physical and equipment. For measuring current, current type, scaling plus safety. Now you have to be careful using a multimeter or a volt ohm meter. You can also measure resistance and do different scaling. We will do this in practice or in practical experiment next. But now you are ready to actually use this meter, and we will cover these three functions. I will show you how to measure voltage, then how to measure current, then how to measure resistance in slides or theoretical manner at first, then in a practical manner. Measuring voltage. Voltage type, there is two types of voltage, which is DC and AC, and we did mention the difference between them earlier. When measuring voltage, the meter probes are placed across the voltage source. The volt ohm meter uses two separate functions and ranges to measure DC and AC. Because AC is constantly changing waveform, measuring AC voltage is not a simple matter. This volt ohm meter measures base weight RMS voltage. And we must mention that when measuring voltage, the volt ohm meter is used to sample the voltage across the source, which is different than when measuring current, where the current in the circuit must flow through the volt ohm meter to be measured. This makes it far easier to measure voltage in a circuit because the operator can simply place the probes across the component as it is wired in the circuit. While in measuring current, the operator must physically interrupt the circuit and solder and connect and insert the volt ohm meter into the circuit. So you might have to unsolder a component, remove its connection so that you can measure the current flowing through it. We must point out that the two voltage measurement ranges, one for DC and other for DC, and we will see how to measure both of these. Now let's look at this digital multimeter or volt ohm meter. We must scale set to highest predictable. If we are measuring resistance and we don't know how much that resistance is, we must put the scale at the highest value. Now the probes must be inserted into the jacks, as you can see here, and we must know the voltage polarity. As you can see in these two batteries, this side is the positive and this battery, this side is the positive. So we must place the positive probe here and the negative probe here to better measure the voltage. Now let's look at how we can measure that battery voltage. Set up the volt ohm meter on 600 volt DC. As you can see here, we are pointing at 600 volt DC since this is a DC battery. We must touch red probe to plus, as in here. As you can see, this is the red probe, and touch black probe to negative, as you can see here. Then we must read the voltage to the nearest 1 volt. As you can see here, this is a 9 volt battery, so it's displaying 9. And you can try this at home. I'm sure that you have a multimeter and a battery. This is a very simple technique, and we must be sure of what we choose. I'm measuring a DC current here, so I choose volt DC. If I'm measuring AC, I must choose volt AC. So you must take a very good care of this setup before start measuring anything. And now let's touch the probe to the negative battery, the red probe. As you can see here, we are reversing the connection, and we touch the black probe to the positive side. We are reversing the connection, and we read the voltage to the nearest 1 volt. As you can see, there is a minus sign here, which shows that the volt is negative since we are measuring it in the reverse manner. And the purpose of this exercise is to show that the volt ohm meter can tell the difference between negative and positive voltages. We must point out that some volt ohm meter, particularly analog type, will not be as forgiving, that putting the probes on reverse voltage can damage the meter. So if you have an analog volt ohm meter, you shouldn't try this. Just place the positive on the positive side and the negative on the negative side. Now let's see if we are to measure another to take another example using a voltage scale that is closer to the actual voltage, showing an improvement in the resolution. So if we know that this is a 9 volt battery, why choosing a 600 volt scale? Or if we know that this battery will measure a volt between 1 and 20, why choosing 600? This will decrease the resolution significantly. In this case, we know that this is a 9 volt battery, so we are adjusting the scale. Now set up your volt ohm meter on 200 volt DC scale. Touch red probe to the positive and touch black probe to the negative. Let's read the voltage to the nearest 0.1 volt, not 1 volt. As you can see, 9.5 volt, which means that we have a way much higher resolution. There is a 0 here. Now if we did another adjustment and placed the volt ohm meter in the 200 volt DC scale, as you can see here. Now let's touch the red probe to the positive and the black probe to the negative and read the voltage to the nearest 0.01 volt. As you can see here, 9.5, and the 0 came here, unlike in the previous example. As you can see, the 0 was here, now it's here, so we have a way much higher resolution. This is a very good example that you must at least have a clue how much the voltage should be or in what range, so that you can get a good result. Now let's look at this 1.5 volt battery example. Set up the volt ohm meter to 20 volt DC. Touch the red probe and the black probe in the positive and negative direction. Using a 1.5 volt battery, read the voltage to the nearest 0.01 volt. As you can see, the reading is 1.52. The 2 here means that we have a very high resolution, and that we can measure in millivolt range, not just volt range. Now let's see the next example, in which we will look at battery, but in the millivolt scale. Now let's set the volt ohm meter to 200 millivolt scale. This scale is reading 2000 millivolt or 2 volts. Touch the red probe to the positive and the black probe to the negative. Okay, now we are using the 2000 millivolt scale. We are actually using the 2 volt scale because 2000 millivolt is the same as 2 volts, but because the display is in millivolt, there is no decimal point in this case. A reading of 1527 millivolt is the same as 1.527 volt. So as you can see here, we are using the millivolt range, and we are setting it here in the volt ohm meter. As you can see now, in this 1.5 volt battery, we can read the voltage to nearest 0.001 volt, and the reading is given as 1500 to 27 volt. It's equal to 1.527 volt. So it's the same, but you just make the resolution way much higher. Now let's see if we want to look at the other example. In this example, we are setting our voltmeter on 2000 millivolt DC scale, and we are touching the red probe with the positive and the negative probe with the negative side. We are using a 9-volt battery, and this is clearly an over voltage situation. Note the reading, it's 1. So you must know what happens if you use a scale that is too low for the voltage being measured. As long as you do not exceed the maximum voltage value of the meter, in this case 600 volt, there will be no physical damage to the meter. The meter indicates an over voltage situation by displaying a single digit 1 at the far left. This overage indication is consistent with the or the other functions to be looked at later. So a 1 means that we have over voltage and we didn't choose the right resolution. Now let's talk about safety in measuring. When measuring voltage, the voltage being measured is exposed to the operator and flowing through the probes. By cautions, be alternative or be attentive. Watch what you touch. You shouldn't touch the probes while measuring voltage. The probes have sharp points so that you can make precious contact. Use the protective shields when probes not in use, so that they won't harm anyone. Observe the meter maximum limits for voltage and current. Fuse are a last resort protection feature. If you blow a fuse, you made a mistake, a very big one actually. So you must spend some time in safety so that you won't get harmed or you won't harm anyone around you. The operators of the voltmeter could be exposed to lethal voltage and current levels. Also, when probing a live circuit, careless cross contact and the resulting short circuits could route equipment, damaging levels of voltage and current to the circuit under test. So you might harm the circuit, damage components while measuring or while using digital multimeter or volt ohm meter. You must practice before going to circuits. You must practice with the components, you must practice with damaged circuits, then go to the real life circuits and real life problems. A good technique is do a dry run of probe placement with power turned off. During the dry run, the operator can see if the probe placement is correct and not short circuiting to damaging voltage and currents. Practice probe placement, and once confident, turn on the power source to make the measurement. Another good technique is to start all measurement at the highest scaling level and then adjust the scale downward to the appropriate level. There are usually automatic protection features in volt ohm meters, but it is best not to consistently depend on them doing their intended jobs. That's it for measuring voltage and for safety in measuring voltage. I know that this lesson was really long, but I'm sure that you learned a lot of things in one lecture, and we kept it connected since these all experiments are related to each other.
Hello and welcome to this new lesson in which I will teach you how to measure volt. So in order to measure voltage, you need to know few things. First, there are two types, the AC and the DC type, as we explained earlier. This watch will measure AC voltage between 2 and 750, as you can see, volt plus the AC sign here. And here it can measure from 200 millivolt up to 1000 millivolt in DC. As you can see, we have a V plus a dash means DC. So first you need to make sure that you are this digital multimeter is turned off. I want to measure DC voltage for this battery. Same for AC if I want to measure AC. For DC, as you can see, I have to go to this range, and I know that this battery is around 9 volts, so I will go with 20 volts. As you can see here, we have it set on the 20 volts, and in the COM I have to connect the two probes between COM and volt probe. So the black to the common, the red to the volt, turn on the watch, and as you can see here we have a positive and a negative. The red will go to the positive and the black will go to the negative. As you can see in this LCD display, we have like 9 volts, and this is the same thing that's written 9 volts DC, and this battery is also 9 volt DC. Same goes for AC. If you want to transfer to AC, if you want to test the AC voltage on your plug or in your house, you need to go to 750 here, and using the same 2 probes, polarity doesn't matter here. You can apply the black to the right and the red to the left, or vice versa. Then turn on the display and it will give you the AC reading here. Same concept applied for both. As you can see, it's very easy to measure voltage using this watch, but you have to make sure not to move from AC to DC while the power is on. You will need to turn off, then move to DC. If you moved from AC to DC while the power is on, you might damage your digital multimeter, so you need to take care of this. So take good care and good big precautions not to do this. Stay safe. Try not to touch the probes when measuring voltage, so you need to touch the probes from this place, not from this place, because you might harm yourself. That's it for the measuring voltage lesson.